patent he transfers to this company. He got $300 only, but that was the first thing that proved that anything that the patents, if you successfully do in the right way, you will get some things out of that. So on the day of that is celebrated, I have already talked to you. Why it is so important? It is important that you see here and there, anywhere from science to arts to commerce to anything else, you can see the effect of the light, and you know that it has effect. The pronounced effect in the events of your medicines, in the events of the surgeries, when it is very useful for making some microsurgeries in eyes, for removing the cataracts and others. And the best thing I can explain to you is the effect of the light, that is the plants kingdoms is using their own systems of the energies or food, whatever may be the case, is known as the photosynthesis. That means synthesis with the photons. And if there is no plant, nobody will be there. So we started from here that how we are benefited from light out of other things if we are not discussing such things here. So based on the light, what we can say, where there is light, there is no darkness. Where there is light, there is no darkness of thinking. Where there is light, there is no darkness of your attitudes. So everything is lighted by any way, that will be glow and that will give at least some output of that. That is very important part of that. For that reason, UNESCO first observed the day in August of 2015 in their head office, that is in the Paris. Afterwards, that was celebrated to celebrate the day of that first applications of the lasers on 16th May of 2016. So that is the things we will celebrate, we will go ahead with that, and we will obviously discover the many things with the lights and its applications like that way. So it is that this year, according to UNESCO, they have designated this year as the International Year of Basic Science for Sustainable Development in 2022. Obviously, we will try to do that through different seminars, some inventions, some patents, whatever may be. It is not within the boundaries of the physics, within the boundaries of the life. We will like everything with these the celebrations of this year's slogans. That is, again, I am talking the International Year of the Basic Science for Sustainable Development, which will sustain for longer than any years, any centuries, even you can say centuries and centuries. So I will not take too much of time for discussing all these things. Many more teachers and hearers who will discuss on that part, and obviously we keep in mind that we will follow the International Day of Light in a sustainable way. Thank you very much for listening to me.
Speaking to us next, we have Professor H.S. Mazi, the Director of Internal Quality Assurance Cell.
A very good afternoon to all of you. Honorable Vice Chancellor Professor Inversion, our mentor, Dr. Manpreet Singh Manna, Madam Inderpreet Ma'am, our Dean Professor T.K. Chatterjee, and Professor Rakesh Kumar Bhartuleshwar, Head of the Department of Physics, Dr. Reena Bhattacharya, all the faculty members of various departments, and my dear students. I, on behalf of the cell IQAC Internal Quality Assurance Cell, would like to wish this program a grand success. I must congratulate the Department of Physics for taking this initiative to celebrate the International Day of Light. A big thank you to OVIC Sina Mahapatur of Physics Department, and also I can see Ms. Pranavi Maji is there. So they have arranged two talks from Professor. One is from Professor Soranshu Mukhopadhyay, who is the professor and head of the Department of Physics of Bardwan University, and another one, he is an engineer of TIFR, Dr. Shubhendu Jwardar. They are in the meeting through online modes. Also have arranged one poster session, poster competition rather. So all these programs will be recorded and will be floated in the YouTube as well as in the social media. And as all of you have come to know from Dr. Manpreet Singh Manna, that we are amongst the 75 institutions who are celebrating International Day of Light this year. And my special thanks goes to Professor Manna for guiding us in this aspect. So I wish this program a grand success. Thank you.
Thank you so much, sir. Proceeding with our program, I'd like to introduce all to our first speaker of the day, Professor Soranshu Mukhopadhyay.
You can go this.
Yes, speaker.
Otherwise, it is difficult to.
Professor Soranshu Mukhopadhyay obtained his MSc and PhD degrees from University of Canada, and he is currently a professor of physics in the University of Bardwan. He has been the head of Department of Physics in University of Bardwan and in Vidyasagar University. Founder, head of the Department of Electronics in Vidyasagar University, ex-head of Department of Computer Science in Vidyasagar University. Currently, he is also serving as the Director of Internal Quality Assurance Cell of University of Bardwan. His research area in photoelectronics, where he, along with his group, has contributed to more than 700 research papers in international as well as national standard journals. He has delivered numerous invited talks in the national as well as international seminars and has functioned as resource person in many refresher courses for colleges and universities. He has served as coordinator and principal investigator of quite a few research projects. He authored 2 books in the area of optical computation and parallel processing. He was the founder editor-in-chief of Vidyasagar University Journal of Physical Sciences. He has received several awards, including the prestigious IETE Award in 2018. Today, he'll be talking to us on the topic Hidden Doors of Light. Sir, I won't take much of your time. We are very excited to hear from you.
Well, am I audible and visible?
Yes, sir.
Okay, well. Now, just before going to starting my talk, I like to thank each of the dignitaries of JIS universities, honorable vice chancellors, deans, head of the departments, and faculty members, students of the Department of Physics, JIS University, that they have given me a scope to speak something about the characteristics of light. And there are a lot of things what we till now don't know in the area of light. And this is a very, very exciting topic till now. And in this topic, I like to tell you, I'd like to spend some time with you regarding the hidden doors of light. That means what we can do with light in near future or in far future. Well, I'm going to my talk directly by some slides. I like to share these slides with you. Well, can you see the slide?
Yes, sir.
Okay. Well, thank you very much. The topic of my talk is the hidden doors in light. That means what are the possibilities within light till now? Okay. And the abstract of my talk is the role of light in future day communication and computation is exceptionally promising. Especially the quantum behavior of light can do a lot to change the global horizon of both communication and light. The role of light in future day communication and computation is exceptionally promising. Especially the quantum behavior of light can do a lot to change the global horizon of communication system with light. This is this abstract of my talk. It is very high speed. In very high speed data processing, electronics show its strong limitations, whereas photonics on the other hand is established as a correct alternative due to several inherent advantages of photon. Again, logic operations are the basic requirement for any type of information and communication technology. The logic-based processors are implemented by various switching mechanisms triggered by different control and input signals. Optics is established as a very strong and reliable candidate for promising different logical devices with tremendous speed of operation, which can never be achieved by any electronic counterpart. These optical photonic logic systems can offer several other advantages in regards of superfast speed of communication, high computational ability and efficiency, SISD, single instruction, single data to multiple instruction, multiple data functions, smaller space and power consumptions, three-dimensional operations, etc. can be achieved by optical systems. In this talk, the speaker will now show the numerous advantages using light, using photonics, optical signal in the domain of information processing to communication. These advantages basically come due to the presence of optical nonlinearity and quantum nature of photon. This is the brief abstract of my whole talk. Well, we know, I'm starting from the very beginning, that four fundamental needs of human civilizations are, if we classify them one by one, what the first fundamental need is food, drinks, and fresh air. This is the first and foremost need of human civilization. And second one, clothes and dresses. Third one, the machine or instruments or processors. And the fourth one is the communications. These are the four different pillars of human civilizations. To continue the wheels of civilizations, we need to strengthen these four pillars as far as is practicable. What is communication? Communication is a two-way process of exchanging opinions, thoughts, feelings, etc. between the individuals through the use of mutually understood signs and symbols. Types of communications. We know the types of communications are, number one is verbal communications, which is spoken or written, and second one is non-verbal communications, wordless message such as gestures, body language, facial expression, eye contact, etc. A brief history of communication. That means in the previous day communication, in the earlier, at the very beginning of the human civilization, the communication we have seen, the communication using the smokes. Smokes are used to send the signal from one place to a distant other place. Human communication was revolutionized with the origin of speech approximately 5 lakh years ago. That means people believe that speech came 5 lakh years ago, and the symbols were also seen from near about 5 lakh years ago. The oldest known symbols created for the purpose of communication were the cave paintings, a form of rock art. Cave painting is a very interesting form of communication in the earlier days. The oldest known cave painting is located within the Servet Cave, southern France. The oldest known forms of writing were primarily logographic in nature, based on pictographic and the geographic elements. The history of communication. The pictures were also the next step of the evolution communication. Pictures were used as the signals. Okay. Now after the inventions of different writing forms or alphabets, there were the necessity of moving communication, that is the communication between two different areas. This leads the discovery of postal. The postal communication was started there. Humans of ancient civilizations used several birds, mainly pigeon, horses, to deliver the messages from one place to another. In the ancient world, many civilizations influencing Egypt, civilizations of Egypt, Persia, Rome, China had efficient postal systems to deliver messages. Now, era of electrical and electronic communications. After the postal communication became the more efficient in the 19th century with the invention of RAC code and telegraphic codes. Telegraph was used first for electrical communication. Meanwhile, the first fax machine was invented in 1843. Alexander Graham Bell invented the telephone in 1876. The first telephone exchange in Britain opened in 1879. The first telephone line from Paris to Brussels was established in 1887. Communication continued to improve in the 20th century. In 1901, Marconi sent a radio message across the Atlantic. The radio broadcasting began in Britain in 1922 when the BBC was formed. BBC came into the picture of communication in 1922. Television was invented in 1925 by John Logie Bird. BBC began regular broadcasting in 1936. Meanwhile, commercial TV began in the USA in 1941. Now, in 1960, the first satellite communication, ECO, was launched. Satellite came into the market of communication in 1960. Bell Labs built and launched the first orbiting communications satellite, Telstar 1. The first geosynchronized communication satellite, Syncon 1, is launched by the US but is lost on the way of geostationary orbit. Syncom 2 became the first successful commercial communication of satellite. On 19th August 1964, Syncon 3 came into the picture of geostationary communications satellite. The satellite in the orbit near the international dateline is used to telecast the 1964 Summer Olympics in Tokyo to United States. In the early 21st century, the internet became an important communication system. Today, email has become one of the most popular modes of communication. Okay, this is the brief history of our global communication picture. Now, if we say about the milestones in the human civilization, actually we are in the 21st century. That means in the peak of the human civilization, and there what we have seen to come into this picture, we have seen several developments, inventions, discoveries, and so on. Crores of discoveries we have seen, but among them, few are the milestones. Few discoveries are the milestones. The first milestone is the invention of wheel. Invention of wheel. That means as soon as wheel was invented, the wheel-based civilization was seen. That means we seen the cart and communication through different carting systems we have seen. Then the next milestone in human civilization is steam engine. Steam engine, when steam engine came, the wheel-based civilization, we are now get more comfortable civilization system that is steam engine-based systems. Our instruments, our devices, our machineries were then steam engine-based systems. And these systems become more comfortable, more user-friendly, and less costly. Then electricity came. As soon as we have seen the electricity, the global picture of the civilization changed, and all the systems become electrical systems. Then the next milestone is electronics. Actually, 20th century is the century of electronics. We have seen several electronic gadgets, several electronic communication systems in the 20th century. We actually at present, from at the time when we are leaving our bed in the morning and till to the time when we are going bed to at the night, each and every moment we are taking the advantage of electronics. Everywhere, every time we are taking the advantage of electronics. This is the era of electronics. Actually, 20th century was told as the century of electronics. Now, scientific community, the engineering community, technological community, they want more user-friendly systems, more capability systems, more system with more capabilities, more capacities, more efficient systems. And they now believe that conventional electronic systems, they are not able to give us the high capacity system, more efficient systems. And that is why people are thinking now about the light or photonics, because they believe, scientists believe that there are lots and lots of hidden advantages in light, in photons. And photon can give us many things. Therefore, we are now at the door to enter to the photonic world. Now, what are the limitations of electronics? Limitations of electronics. Now, here we see that electron is a Coulomb particle having mutual interaction. This is a problematic one, because if the particle which is carrying signal, they are mutually interacting, then they will be less conscious about the duty what to be performed. And we know that electron is a charged particle, and therefore always they are suffering the Coulomb interaction between them. And this is one limitation. The second limitation is response time in material cannot generally cross some nanoseconds. That beyond nanosecond operation we cannot expect from electronic system. That means the response time of electronic device is at most 1 nanosecond. Beyond that it cannot go. and therefore it cannot give us the speed of the system beyond the gigabits per second. Then the third disadvantage of electronic system is von Neumann bottleneck problem. It's a very common problem in electronic instrumentation, electronic devices. No WDM facilities, wavelength division multiplexings are not seen in electronics. Again, suitable in Boolean logic, but not compatible in tri-state quaternary state logic. Because if I give you a task to add two numbers, let it is 5 and 7. What you will do if you use computer or laptop, what you will do, you will give 5, you will give 7, then you will give the instruction addition, and after getting your instruction, what the computer will do, they will first convert 5 into the Boolean 5. That means 0, 1, 0, 1. 7 to this Boolean 7. That means 0, 1, 1, 1. Then they will add one by one. Because the computer, the data processors, all of them are electronic systems presently. And therefore, they do not know other than Boolean operations. Only they understand 1 or 0. That means signal present or signal absent. They do not understand 2. They do not understand 3. They do not understand -1. This is the problem. It is not, therefore, the electronic systems are compatible in Boolean logic so much, but not compatible at all to do tri-state logic, quaternary state logic, decimal state logic, so on, so on. And there are many other limitations. I don't want to take time to telling the limitations of electrons. The next limitation is the important limitation: electron has mass. It has rest mass. As it has rest mass, therefore, to move an electron, we need sufficient energy. Otherwise, it cannot move, and therefore, it has rest mass. It has spin. It has spin and half integral spin, and it obeys Fermi-Dirac statistics, FD statistics. It is called the Fermi-Dirac statistics. And because of that, single electron stays in a single electronic energy state. That one energy state cannot be shared by other electron. Electron prefers very much to share its own room by itself. It doesn't know how to share its room with other electrons. This is a problem. That means in one energy state, it is shown by both Fermi, Enrico Fermi and Dirac. These characteristics of electrons were shown by both of them, Dirac and Fermi. People now started to think about the optics or photons. Because of those limitations, it is not difficult. It is very difficult to get very, very high speed computer. That means present day computer, if you go to the bottom rightmost places of your laptop, you will see the speed of computer. It is in the order of megahertz. Or if it is a very good computer, it is a super fast computer, it is in the gigahertz. But it cannot go beyond that speed because of those limitations, what I have just told you. Because of those limitations, electronic system cannot give you terabits per second operation, or it do not know to work with femtobits per second. It's very difficult for electronic systems. Okay, therefore, people started to think about optics or photon as information carrier instead of electron in communication, information processing, computing, image processing, etc. Since the middle of the last century, people started to think about optics or photon as information carrier instead of electron in the communication from the last century. Okay. Now, the question is that why photon? Photon has many hidden and inherent advantages. I have told the topic of my talk is that the hidden doors of light. The inherent advantages, inherent gates of photon or light are these following. Okay, photon has many hidden advantages. Cost advantage, it has no charge because photon is electrically neutral. It has no rest mass and it obeys for Bose-Einstein statistics. That means spins are integral. And no mutual interaction, as it has no charge between a photon, therefore it doesn't suffer any mutual interaction between two photons. No crosstalk you will see. In case of electronic system, crosstalk is a very important problem. Because in crosstalk we have seen that channel, that signal of one channel goes to the signal of the other channel without your permission. This is crosstalk. But in photonic system, crosstalk can be fully avoided because crosstalk is coming mainly because of the mutual interaction of electronic signals. But here in case of photon, no mutual interaction is there and therefore no crosstalk is there. And then the next advantage is the real-time operation. Photonic operation is so high speed, you can call it real-time operation. Real-time operation means the speed, the time required to do an operation is so small, so small. Therefore, you can tell them it has used no time to do the operation. That is called the real-time operation. Actually, photonic system can do an operation in the time of femtosecond. Practically, it is so small time people can call it a real-time operation. No use of time to do an operation. And because of this real-time operation, the speed of operation of photonic system goes very high. Then photonic channels have very high bandwidth. You know, optical fiber. Optical fiber is a photonic channel. Optical fiber is a photonic channel. And in optical, because of the optical fiber, we people are now using the advantage of internet. Actually, sitting in Bardwan and you are sitting in JIS University, Kolkata, and I am talking, you are hearing. This is actually happening because of the advantage of optical fiber. Because optical fiber can bear crores of signals at a time. Lots and lots of signal at a time, and therefore the communications become very much easier because of optical fiber. You will be surprised to know that the whole data content of India is going to US or is going to Australia, is going to Germany only with a few bundle of optical fibers. Total Indian subcontinental data are going to US only through a bundle of fibers through the ocean. Therefore, tremendous data carrying capacity optical fiber has because its channel bandwidth is very large. And you know, at present, you are sitting at the top of the globe, and in the just opposite side of the globe, a student is sitting in US library. US and India in just two opposite sides of the globe. And here, within only 1 second, I am again repeating this time, in only 1 second, we can send the total contributions of Rabindranath Tagore from India to US. Total contributions of William Shakespeare from Oxford to India, only in 1 second. Why? Because the tremendous data carrying capacity of light through optical fiber. That is because of high channel bandwidth of optical fiber. The next advantage of optics is many photons can stay in a single energy state. In a particular single energy state, large number of photons can stay. Where in case of electronic system, only one electron can stay in one system. I think those students who are here in front of me, those who are Bengali speaking students, there is a very well known proverb in Bengali. I am taking the advantage to tell this, that Jodi hoi sujon tetul patay nojon. That means if we are very much friendly people, then in a very small place we can accommodate ourselves. In case of photon, it is said that in a very small place, in a only single energy state, large number of photons can stay. That therefore photons are united. Photons are united, and that because of unification of photon, it can do a lots and lot of works what cannot be thought with electrons. I like to share you one very interesting story regarding the characteristics of photon and electron. Once upon a time in Rajabajar Science College, Calcutta University, once upon a time, Professor Asian Bose was then alive, and one international conference was organized by the Calcutta University at the time. And in that conference, Professor Enrico Fermi came as one invited speaker. Enrico Fermi, you know that the Enrico Fermi is the inventor of the electron characteristics. And in the same conference, Professor Asian Bose was there, and he was the inventor of photonic characteristics, Bose-Einstein characteristics. That means the characteristics of photon. And after the conference, when the conference was over, 2 cars were allotted. One car was allotted for taking Professor Asian Bose from the conference place to his home, and another car was assigned for taking Professor Enrico Fermi from the conference place to his hotel. Fortunately, the way of journey was same for both the 2 cases. For both the 2 cars, the way of journeys are same. And you know, those who are well acquainted with the lifestyle of Professor Asian Bose, they know that Professor Asian Bose loved to stay with his students always. He was a very student-friendly professor. And in Professor Bose's car, a large number of students were there. And in Professor Enrico Fermi's car, only he was alone. And Professor Enrico Fermi instantly told Professor Bose, Professor Bose, please send some students from your car to my car. Instantly, Professor Bose told that no, Professor Fermi, it is according to your statistics and it is according to my statistics. It is a very beautiful joke regarding the characteristics of photons and characteristics of electrons. And there are many other advantages of photons are seen. Advantages of optics over electronics in information processing. I am now coming in information processing, that is the computation. Computation, in case of optics, a high degree of inherent parallelism. I am again repeating the statement, the inherent parallelism is seen in case of optics. That means optics can do the works at a time, different works at a time. Light can do different works at a time. Just I am giving you an example. Suppose you are given those people who are, those students who are from the physics background, they know that the logic gates. You know NAND logic gates. Suppose by electronic transistors or the FETs, you have developed one NAND logic gate. And that one NAND logic gate only do one NAND operation at a time. It cannot do NOR operation, it cannot do XOR operation, it cannot do AND operation, only NAND operation it can do, because the gate is designed for doing the NAND operation. But if it is a photonic device, it can be seen that at a time with the same device, you can do NAND operation, you can generate OR operation, XOR operation, several logical operations. This is parallelism. This is parallelism because you have 2 hands. By one hand, you are drawing a sketch, and by another hand you are cooking. Okay, this is parallelism. In case of electronics, you cannot expect the parallelism. But in case of light, photonics, you can expect the parallelism. As if there is parallelism, and therefore the speed of operation becomes very high. Second one, I have already told you, the real-time operation. Third one, processing at submicron dimension. The cross-section of a light beam can be minimized to the nanometer scale. Therefore, a beam of light in the range of nanometer can be developed. But a beam of electrons in the cross-section of electrons with the nanometer range, it is difficult. Therefore, with the light, we can do the work at the submicron dimension. Even in the nano dimension, you can do the operation. Suppose you have developed a nano device and you like to operate the nano device. You need the light, not the electrons, because of the diffraction and so other reasons. By light, you can interact. Light has no crosstalk. Single instruction, single data. In technology is a very important term. Single instruction, single data. That means at a time there is a single data and instruction is single. Electronic systems are comfortable to do this operation, SIST. But photonic systems can do multiple data, multiple instruction, multiple data operation. What is the multiple instruction, multiple data? Suppose you have a system. You have a system, and this system there is a NOT gate. NOT gate is doing operation on the input A, and same system is doing in the NAND gate. It is doing the operation with B and C. The same system is doing the XOR operation. It is doing its operation in E and F. Therefore, the data are different. Instructions, that means and or not, they are also different. That means parallelly, the system is doing work parallelly. All the operations are happening parallelly. But the system is unique, one system. It can be thought in case of light. Okay? And 3D operations, you can organize the 3D operations with light, 3-dimensional operations. In case of electronics, you cannot generate 3-dimensional image. Still in computer or laptop, you can develop 3-dimensional image, but they are not in real sense, they are not 3-dimensional image. They are 2-dimensional, they are 3-dimensional image in scanned 2-dimensional. Scanned 2-dimensional. Actually, they are not 3-dimensional. But in optics, in holography, you can record 3-dimensional objects. You can reconstruct your object from image from the 3-dimensional in the holography. In hologram, we can record and reconstruct 3-dimensional images. Well, WDM, WDDM facilities can be achieved in optics in light. Okay. Therefore, with light, we can do lots in communication. In present day, if you, I'm just giving you one idea. If you tell the total global communication is 100, including your satellite communication, television communication, mobile communication, internet communication, radio communication, whatever communications are there, total communication is 100. And among them, more than 90% communication is done by optical fiber. The advantage, the tremendous advantage of communication we are enjoying today, that is because of light, that is because of optical fiber. You know, a shopkeeper, a farmer, a scientist, an engineer, a minister, all of them are using mobile telephones. Okay, mobile telephones. And mobile telephones are there using because broadband advantage of mobile communication, it can handle the broadband communication. And behind the mobile communication, there is optical fiber network. Okay, and the communication, today's communication became very, very much easier because of the contribution of optical fiber in world of communication. Actually, in case of optical fiber, the inventor of optical fiber, he was given the Nobel Award, because he told once upon a time that if we use optical fiber in communication, we can see the global revolution. And therefore, what is my essence of talk? That in civilization, I have told you, to continue a civilization, we should strengthen the 4 legs of civilization. One leg is food, other leg is dress, other leg is house, and the 4th leg is communication. Till now in the 21st century, we are not very much efficient. We cannot say that we did revolution in food. Lot of people in the world till now are getting not food, not proper nutrition. Lot of people in the world currently are not getting proper dress, clothing. Lot of people are present currently are not getting proper housing, lodging. But in case of communication, we did the revolution. From the grassroots people to the high society people, everywhere we have created the revolution. That revolution in communication is only became possible because of the invention of optical fiber. Okay, now the burning issues of communication. Is speed, capacity of carrying data, cryptography, that means data security, and cost. Use of optics in communication, that means optical fiber in communication. Speed of communication has been enhanced a lot because I have already told you that in 1 second we can send the total contribution of Rabindranath Tagore or Leo Tolstoy from India to US, because speed of communication is so much and so much high. Capacity of carrying data. At a time, how many data is carried by optical fiber? This is also supported by optical fiber. 4th one, cost. As you know, optical fiber is coming from the glass. Glass is very, very less costly, and therefore in nature sand is available lot, and from sand glass is prepared, and therefore cost of optical fiber is very small, very low. Now, but the problem is that the 3rd problem in communication, cryptography. Cryptography is a very important problem in communication. You know, cryptography means using the broadband channel, I like to send my own data to a desired place, from a particular place to particular place, not for all. And in this case, we have seen the hacking, question of hacking. This is a very, very burning issue today. And therefore, you know that today hackers are the electronic engineers. They are very, very much capable to hack a data. And this cryptography, data security is very, very important in financial sectors, banking, in defense, and so on. And therefore, people in those areas are very, very much worried about the hacking of data, cryptography. There are a lot of conventional cryptographic systems. but they are under question. No cryptographic system at present stands for a longer time. After 1 or 2 minutes, every cryptographic encoding system is removed because of hackers. Hacker can get well equipped about the decoding of data, and therefore the people are very much worried about the security, data security, and then the people then are taking the help of the physics people. Then physics people, what they are telling? They are telling that you use light as the signal for communication. And not only light, light has well-known quantum property. If you use the quantum cryptography, quantum property of light in communication, no one can break your signal. No one can decode your signal. You are sending your signal using the quantum property of light. This is called the quantum cryptography, quantum property of light. And in case of quantum cryptography, you know that you are sending your data, receiver is receiving his data, but if receiver understands there is a scope, if receiver understands that what data he is getting from the sender is already broken, then he will tell the sender that stop your sending data. In case of quantum cryptography, there is a scope of using quantum property of light, and currently it is a very promising one, very promising one in the field of communication, quantum cryptography. This is the very important gift of light. Okay, I have a lots of slides, but time is not, I think how much time is there for me? Madam, can you hear me?
Yes, sir. It is 40 minutes total given.
It is about 40 minutes, but I think 40 minutes is over already. Can I get 5 minutes more?
Yes, sir. Yes, sir. Please continue for 5 minutes. No issues.
Okay. And these are the systems. These are the systems. In case of light, what you can do? In case of electronic system, you are forced to confirm using the Boolean data. But for light, you can generate tri-state data, quaternary data, decimal data, and so on. Okay, encoding of bits. Binary logic is easier for our electronic system, but tri-state, decimal state, multi-valued states can easily implementable by optical systems. Okay, these are the bits 0 and 1 for binary systems, and trinary system 0, 1, 1 bar, and so on. It can be implemented. And I'm showing you here an optical converter without help of any electronics. No electronics is there. You have an optical converter where the decimal data is converted to binary and binary data is converted to decimal. This converter was invented by me long back, and in a very well-known world-class journal. It was published at the time. It was in the time of 1991, and in Optics Communication it was published. That means the conversion of decimal to binary and binary to decimal without help of electronics. Now, I'm coming to this thing that to get the optical operations, that is the counterpart of electronics. Now we understand that optics has a lot of advantages, and therefore to do the optical computations, to do optical communications, to do optical processing, we need some optical switch. And in case of light, there are some optical switches. these switches are called the nonlinear switches. These switches are called the nonlinear switches. Okay, I'm not explaining about the switches in detail. I'm not explaining about the switches in detail, but using the nonlinear switches, we can do operations with light without the help of electronics. And therefore, as there is no help of electronics, no contribution of electronics, no role of electronics, therefore speed becomes very, very much faster, very much higher. Okay. Well, now my time is too short, but I have to tell you lots of slides, because I have finished only 38 slides, where in my capacity there are 104 slides. But however it is, I would like to discontinue here, just telling few sentences about lights. People now in the that means in the 2022, people are now confident that if we can use the advantages of lights, if you can use advantages of light, the hidden advantages of light, many doors of civilizations becomes open. You go to the computer science, the doors of artificial intelligence, the doors of high-speed computations, the doors of parallelism, all the doors will be open. All the doors will be open. You can get, I think, you cannot expect what we can get using light. Not only in computation, you go to the field area of any branch of science. That means in case of high energy physics, where high energy is energy is required, and there you can use the laser. You can use laser to get fission and fusion also. Today, laser is capable to do the fission and fusion. That means the high energy can be obtained from the laser. And you know, carbon dioxide laser is a very, very important laser today. It can cut one iron plate of thickness 1 meter in 1 second. So much energy it can offer. In starware, people are using carbon dioxide laser. You will be surprised to hear that using carbon dioxide laser, some lunar torch is now developed. She's sitting in the surface of the earth. People are developing one torch, and using the torch, he is seeing different areas of moon. Different areas of moon, because carbon dioxide laser is so much powerful today. Therefore, if you like to get power, you can get light everywhere. In case of, suppose, in case of zoology, biology, physiology, there also light is tremendously used. Because you know microsurgery. In case of microsurgery, the surgeons are doing operations in a very, very small time without any shed of blood. They are doing operations using the microsurgery. What they are doing, they are making some 1 or 2 holes in your abdomen or in other places, and they are entering some optical fiber. Through one optical fiber, they are sending light and illuminating this place where to be surgeon, and by the other hole, they are sending the micro instruments and they are cutting the places. Just few days back, I was talking with a very important surgeon, and I was discussing with him that I am telling that currently surgery has become very much easier. And now what he told me, it is not the credit of medical people, it is the credit of optics, it is the credit of science, optical physics, it is the credit of optical fiber. Therefore, everywhere you can, if you want to get light, you have to use light. Few years back, you know, gravitational wave was detected, and To detect the gravitational wave from the collision of black holes, some wave came, and to detect the gravitational waves, people used some sort of optical interferometer. And by seeing the shift of fringes, the gravitational wave was detected. Therefore, everywhere you must use light, the characters of light, to get more and more advantages in civilization. To extend your horizon of civilization, you must use light. You know 2015 was celebrated as International Year of Light by UN and UNESCO jointly. 2015. Why 2015? If you go to the 1,000 years back, one scientist in Iraq, his name was Al-Hatham. Al-Hatham, he was the first scientist in the world. He wrote 7 volumes of optics. Its name was Treatise in Optics. 7 volumes with light, the first scientific book in the world. And to celebrate his work, to commemorate his work, 2015 was celebrated as International Year of Light. And 2015 was the Maxwell's development of Maxwell's equation, 150 years of Maxwell's equation. And therefore, International Year of Light was, because behind the picture of light, the theory of Maxwell's equations are important. And therefore, 2015 was celebrated as International Year of Light. And each year, 16th May is celebrated as International Day of Light. I think it is not very, if you go to the subject, International Year of Physics was there, International Year of Chemistry was there, International Year of many things were there. But within the subject of physics, a channel is light, a sub-subject is light, and there is no other example where a sub-subject was celebrated as International Year. It is only for light. I like to conclude with one important statement. If you go to Bible, you know Bible, I think all of you know Bible. If you go to Bible, in the first page of Bible, in the first paragraph of Bible, you will see this line, that as this line is that light is there. This line was there, that as there is light and everything is clear. That means before creation of everything, God first created light. God first created light. In Bible you see that God first created light, and then after creation of light, he developed, he developed the land, he developed the hills, he developed the ocean, and so on, so on. The famous statement in Bible is that God said light and there was light. The first creation of God was light, according to Bible. Therefore, because God knew that light has enormous scope, I am seeing you, you are seeing me, everything is visible because of light. And therefore, God first created light, then he created the other things. Okay, and at the time of conclusion, I like to tell you one thing, that light gives us everything. It helps us to do everything. We are doing everything because of light. Okay, but there is a tremendous darkness within light. This darkness, till now, physics people, scientific community are not acquainted with the darkness, because till now we do not know why the C cannot be greater than C. The velocity of light cannot exceed the free space velocity of light. There are a lot of hidden questions in the light which are till now unanswered. and people, scientific community are trying to explore the darkness of light hidden within the light. Thank you all. If you have any question, you can ask me.
Thank you so much, sir. I'm sure when I speak on behalf of everyone, I'm sure I can speak on behalf of everyone when I say that this is a very interesting topic you told us about, and we look forward to hear more from you. So, thank you so much. I'd like to call Professor Avik Sinha.
Any question?
Question, anyone?
Sir, I have a question.
Yes.
Am I audible, sir?
Yes, you are audible. Please ask.
Sir, in case of electronics, we are having several kind of circuitry, several kind of processor designing, and those are accompanying the market for the last 15 or 20 years at a stretch. But in case of photonics, we are not finding such kind of thing happening for years. That what is the reason behind that, and whether there will be any possibility to replacing electronics in case of circuitry by photonics?
Yes, that is a very good question. Actually, the target of the people of scientific community is that to replace all the electronic systems by the photonic system because of speed, because of miniaturization, because of cost, and there are several reasons. But till now, there are very much several difficulties, because the number one difficulty is that in case of electronics, the storing of data is very much easier. But till now, in case of photonics, the storing of data in form of light, it is comparatively difficult. The operations, actually photonic systems, it is coming. It is not of the current days. It is coming after 10 to 15 years, it will come. Actually, developments are going on. And the photonic circuits, to replace an electronic circuit, you need a photonic circuit. To replace an electronic architecture, you need a photonic architecture. And these are to be done. But there are some problems. And people, scientific community, they are trying to resolve these problems in different places and in partial places. That means they are now in communication. Suppose in communication, the data are carried by light in through optical fiber. But when the optical fiber is coming to the land, the data is coming through you by cable, electronically. Till now, electronics is not replaced because the alternative of electronics is not successful till now. But we must do the alternative of electronics. Because actually, if I give you this example, that you see the national highways. In case of national highways, to make the communication comfortable, we need two things. First, the speed of the cars, speed of the tracks. Okay, speed of the vehicle should be very high. It should be greater than 100 km/h. And at the same time, in the loading and unloading places, if your speed of loading and unloading cannot be made so much high speed, then the same problem will come. Same thing in internet highways, in communication highways, data are coming with very high speed, with the speed of light. But as soon as it is coming to your laptop, your computer, what happens? The speed becomes very slow because it is electron. And therefore, the optical scientists, photonic scientists, what are the duties for them? Their duty is to replace the photonic electronic circuits by optical circuits. It is under research. Lot of photonic institutes are doing now to develop photonic devices. And fortunately, the nanophysics, nanoscience, nanotechnology, I think you have heard about the nanotechnology. The nanotechnology systems are very much usable with photonic systems. Photonic systems are very comfortably used in nanotechnology systems. And therefore, this is photonic systems are not complete now. It is partially developed. I think I can tell you that if the total photonic system is, if you mark it by 100, only 10 to 15% we have developed till now. And because of our limitation, 85 to 90% development in photonic systems are till now not done. It is under research. Institutes are doing research to resolve the matter. Am I clear?
Yes, sir.
Thank you so much, sir. Now I'd like to call our Professor Leena Bhattacharya to give the certificate of appreciation.
Mr. Mukherjee, please accept it. Of course, it is partially.
Thank you very much. Thank you very much for the nice certificate what you are offering to me. Lot of thanks to the authorities of JIS universities, physics department of JIS universities, organizer of the seminar. Thank you so much.
We are hearing from you later for a convenient day.
Okay. Well.
Thank you, sir. We're going to have a small tea break now, following which we'll have a poster presentation and competition by the students of our university. The competition will be judged by two of our deans, Dr. T.K. Chatterjee and Dr. Rakesh Kumar Bhargava. I request all the participants, our jurists, the guests to be there at room number 614 at 3 p.m. sharp, 3:15 p.m. sharp. We shall come back here at 4 p.m.
Okay, do you allow me to leave?
Yes.
Okay, I'm leaving. Thanking you all. I'm leaving the place. Professor Bhattacharya, I am leaving.
Okay. Thank you. We're going to come back here at 3:45.
Okay. Well.
Ovik sir.
Yes, sir.
Ovik sir, please come in. Ovik sir.
Yes, sir.
একটা মোবাইলে চালিয়ে নিন,
Okay.
রেকর্ডিংটা পজ করা আছে, আপনি এসে চালিয়ে দিলে হবে। একটা মোবাইলে জুম অন করে নিন আর এটাতে অ্যাকসেপ্ট করিয়ে নিন।
Accept করে নিন।
আর এখানে হ্যালো অভিক স্যার,
আচ্ছা বলুন।
এখানে শেয়ারিংটা স্টপ করে যান। আপনি সার্টিফিকেট শেয়ারিং করে দিলেন না, ওটা স্টপ করে যান ল্যাপটপে। হ্যাঁ, এবার যেটাতে আপনি আছেন ওটার ভিডিওটা একবার অন করুন। এখানে স্টপ শেয়ারিং করে দিন। এটা না, এটাতে আপনার স্ক্রিনতে আছে, জুমে গিয়ে স্টপ শেয়ারিং। হ্যাঁ, আপনি যেটাতে চালিয়েছেন না জুম, সেটাতে একবার ভিডিওটা অন করুন। যেটাতে জুম চালালেন ওই ভিডিওটা একবার অন করুন। হ্যালো, হ্যাঁ ঠিক আছে। এখানে আপনি ওই পোস্টার সেশনটা তুলে নিন। হ্যাঁ, আপনি মিউট আছেন কিন্তু। ঠিক আছে।
চলো।
Yes, there is no sound.
The sound is there, but video is not visible. Are you able to hear me?
Those who are in the poster session, please enable the sound. Avik, Dr. Avik, yeah, please enable the sound. Dr. Avik, please come in. ম্যাম গুড আফটারনুন ম্যাম ওই 19 তারিখের মিটিংটা কুড়ি তারিখ কখন? আচ্ছা তাহলে ওটার জন্য আলাদা কোনো নোটিশ করার দরকার হচ্ছে না তো? করতে হবে না মানে আপনার না থাকলে তো লাভ নেই। আমরা তো যেটা বললাম না রিভিউ করবো 5 ইয়ার্স একাডেমিক অডিটের ডেটাটা বা ফর্মটা ড্রাফটিং করবো তাহলেই হবে, আদারওয়াইজ তো ইফেক্টিভ কিছু হবে না। ওকে তাহলে 20 তারিখে ওই এমডি স্যার আসছেন এবং সেটার জন্য আমাদের কোনো নোটিশ করতে হচ্ছে না, তাই তো? আচ্ছা তাহলে আমাদের একটা এমনি প্রি শিডিউল ছিল 18 তারিখ মানে আগামীকাল, ক্রাইটেরিয়া ওয়াইজ দেখা তাহলে ওটা আমরা এমনি শিডিউল করে নেব। হ্যাঁ আমি জানি ম্যাম, ওটা আমি এক্ষুনি পাঠিয়ে দিচ্ছি। আর আরেকটার জন্য ফোন করলাম যে ওই যেটা ওই মান্না স্যারের সঙ্গে অনলাইন ছিল ওইটা তাহলে ওই সৌরভ আমাকে বলছিল আমায় মেল করতে, কিন্তু মান্না স্যারের সঙ্গে ওই যে মিটিংটা ওইটার জন্য মানে মেলটা কি আমি ইস্যু করবো? হ্যাঁ মানে আমার তো সেটা হলেই সবচেয়ে ভালো হয়। ভেরি গুড, সেটা করলেই হবে কোন। আর আমি একাডেমিক অডিটের মার্কস চেয়েছিলেন ওটা দিয়ে দিলাম। ঠিক 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 আছে না, ঠিক আছে তাহলে আমরা কালকে ইন্টারনাল যেটা আছে ওটা করে নিচ্ছি। ঠিক আছে ঠিক আছে, থ্যাংক ইউ।
So one person is that is
the intensity is not that huge. And stagnant. So the that is why the gas is stable. But if you take it out and suddenly obviously.
that is happening. But in the state of constant battery, there's photo cell. That is the order. That is also
Rather that would make more
photo cell.
that would be getting automatic.
There no external stimulants like the battery storage.
Not all of our streetlights work as lot of money.
No, initially you are investing money. Subsidy is there from the government of India and the government of Uttar. They are giving the subsidy for the
More than that, and more than that, the energy is being used by those that is after the household utility. You can just sell the this person.
right.
That is also
in small places. Suppose there is we have
that will be the 12 hours or 13 hours like that. So photosynthesis is always that's another way of showing.
But that is not what you
Actually, some symptoms presented actually most of the cases are operating the same light on system.
what is
What is yeah, something. What exactly? Because most of the things that in market, any time automatically they recognize it. Okay. But however, you are very presentations and you
us to meet our second speaker of the day. Let me introduce you to Dr. JISU-PHARMA.
Yeah, I'm just getting ready for the presentation. So I'll try to share the screen, but it says host disabled participant. So can you please enable that? Hello, are you able to hear me?
Yes, sir, we can hear you.
Yes, ma'am. Yeah.
Dr. JISU-PHARMA did his MS from IIT Madras. Presently, he is working as engineer at Tata Institute of Fundamental Research. He has more than 20 papers in reputed journals. He has published 3 books from India and abroad. He is reviewer of many reputed journals and he has given plenty of interviews. Sir, it is so nice to meet you and we are very eager to hear from you. I won't much of your time. Yes.
Hello, is this visible on the screen?
Yes, sir, it is.
Okay. Good evening, ladies and gentlemen. On the eve of International Day of Light, I am highly delighted to have received this invitation from Professor Madam Veena Bhattacharya, Head of the Department of Physics, JIS University, Kolkata. I also thank all the JIS University members who have organized this event. Today, my topic is the laser technology. So I will try to highlight some of the uses of lasers that we are using in our daily life with some starting warm-up basics of laser, and that should not be very difficult for the students community. So in short, what is laser? Laser is actually the short form of light amplification for stimulated emission of radiations. So basically it is a narrow beam of light of single wavelength. It's a monochromatic in which each wave are in phase with the other. So this is called coherence in time and coherence in space. So they are all aligned in one direction and they are having the same phase, each of the photons. And to generate this kind of emission, we use an apparatus that's also called laser apparatus. It is a device that produces an intensive, concentrated, and highly parallel beam of coherent light. So the background of laser is the tools that are given by Einstein, his knowledge about the atomic structure, Bohr's atomic model, or it says that atom is composed of nucleus and electron cloud, and if an incident photon is energetic enough, it may be absorbed by an atom, raising the later to an excited state. So from one energy level, the atom, the electron inside an atom can go to another higher electron level state and then remain there for some time and then fall back to an intermediate level. And from there, it after spending much of its time there, it can again drop back to the ground state. So while from this intermediate level, when it comes back to the ground state, it emits light. And if we have several such emissions, they are all coherent photons and directed in the same direction, and that is the basic of laser. So in 1917, Einstein pointed out that an excited atom can be reverted to a low state via 2 distinct mechanisms. These are the spontaneous emissions and stimulated emission. which we will browse through them later. Now, the word laser actually came from maser, and we also call maser as the father or forefather of laser. So maser stands for microwave amplification by stimulated emission of radiations. On the screen, you can see three persons who were the inventors of this instrument. The maser was first built at Columbia University in 1953 by Charles H. Tolles, James P. Gordon, and Herbert J. Ziegler. So masers are used as the timekeeping device in atomic clocks and extremely low noise microwave amplifiers in radio telescopes and deep space communication ground stations. Now, the purpose of using these masers is to use the purpose of using the atomic clocks is basically the atomic clock is the highest accurate clock known as of today. So the accuracy of this is about 10 to the power minus 9 to 10 to the power minus 12 seconds per year. So this is basically used in radio astronomy. We use it a lot because when we combine data from two separate observations, then we need to interrelate those two with time. So nowadays we see that we do a lot of observations from different observatories all over the world and try to combine them to produce a more clear, distinctive image of the radio source, the celestial object. So there comes this time. We have to make them coherent in time. For this time coherence, we use this, where masers are used. Now about laser. This laser is same as maser, except M is replaced by L, that is light. So the first laser was built in 1960 by Theodore M. H. Neumann at the hugest research laboratories based on the theoretical work by Charles Hart Forst and Arthur Leonard Schawlow. So it produced a coherent beam of optical radiation. Energy levels of electrons orbiting the atomic nucleus is pumped. Pumping is a mechanism where we excite the electrons from the ground state to a higher energy state. And this pumping is usually done by stimulation with radiation from another source falling on them. And when these electrons fall down, as I said earlier, that they emit laser emission because they are coherent in nature and a lot of photons are generated. Now, these are the properties of laser. The laser emits in a single wavelength. Ordinary white light is a combination of many colors or wavelengths of light. Laser emits a light that is highly directional with low beam divergence. That is, if you take a laser beam, if you measure the diameter of the laser beam at one point, if you go several kilometers away, you will see the divergence of the beam may be about 0.1 to 0.1 to 10% of divergence you can see there. So they are highly directional beam of light. Laser emits coherent light. The wavelengths of laser are in phase in space and time. Ordinary light can be a mixture of many wavelengths. So laser is in a single wavelength. So these above three properties can make the laser emitted light more hazardous than ordinary light. So the energy in the laser light is so intense that it can be used for welding, surgery, and many other places we can use laser. Even in defense, we are using this laser for destroying other equipments of our enemies. And in this regard, America is one of the most advanced countries in this technology. Now, this is what the type of other sources of light as compared to laser light. On the top, you can see that the white light radiates in many wavelengths. As you know, the spectrum of a rainbow, and the source also emits in various directions. That is, the beam keeps diverging. On the other hand, a monochromatic source of light is also diverging, though they may be in phase or they may be in they have single wavelength and may or may not be in phase. Whereas a laser light is not only in phase with other other waves that is generated with it, but they are also traveling in the same direction and making it very intense light. So for a laser, first absorption of energy is taking place by the atoms, then spontaneous emission, and the basic mechanisms of laser consist of absorption, spontaneous emission, stimulated emission, and population inversion. Absorption, we all know that when an atom is hit by some photon energy, some of its electron may go to its higher state. These two are E1 and E2 represent the two energy levels, and the energy absorbed is E is equal to h nu, where h is Planck's constant and nu is the frequency. And when they fall back, spontaneous energy emission is an excited atom emits a photon and moves into the state of lower energy. The energy difference, delta E, between the two states determines the wavelength of emitted photon. And stimulated emission is a photon having an energy, delta E, is required, which interacts with the excited state, resulting to the emission of another photon having the same energy. That is an external energy photon of same wavelength if it strikes an excited atom whose electron is already in the higher state, and when it comes down to lower state, it also emits in the same wavelength, and these two wavelengths may have coherent. They can be coherent, these two waves, and thus they generate higher intense light in one direction. This second photon is identical with the primary inducing photon having same energy and propagating along same direction. Both exhibit identical wavelengths, phases, and directions of propagation. Now, this is a typical representation of population inversion, which is the essential tool for a laser. So all there is a gas or a liquid or a solid inside a laser, whose atoms are used for generating these photons. So some of this, most of this will be in ground state. It depends on the temperature also. The electrons will be in the ground state, and when some energy of is induced on it, these some of the electrons will be raised to the excited state, into a higher energy level state, where it may stay for about 10 to the power minus 7 state. So it is minus 10 to the power minus 7 seconds. So it is called a unstable state. It stays there for very small time period, and they fall back to an intermediate state where they stay relatively 1,000 times more duration, for more than around 1,000 times more, or 10,000 times more they spend in this state. That is called the metastable state, where usually it is about 10 to the power minus 3 seconds, and then they get collected there. So the population of the electrons in the ground state reduces, whereas the population in the metastable state increases. And so when they fall back, they generate simultaneous emissions of single frequency photon, and they are coherent, so thus generating this laser light. So the population inversion can be stated as when the number of atoms in a metastable state becomes larger than the ground state. It is called population inversion. So the electrons in this metastable state should be more, and that state is called population inversion. For inversion of population inversion, we have to pump in energy, and that is called the laser pumping. So there can be three types of pumping: optical pumping, electrical pumping, and chemical pumping. Some of them we will be seeing. In optical pumping, we have this is suitable for solid lasers, solid state lasers, and for electrical pumping is suitable for gas lasers, and so on. So this is a basic laser system. So here you can see that there are two reflectors. These are basically one on the right side. The reflector is partially transparent, or you can say it is a translucent reflector, where some portion of the waves that is inside can escape through this side. So this is the side where the output laser beam is produced. The length of the two, or the distance between these two reflecting surfaces are adjusted depending on the wavelength. And energy, the material in which whose atoms actually generate this laser beam are kept in between. For example, a ruby laser, you will keep the ruby crystal in between these two mirrors. Then we will excite the atoms of this crystal by putting into energy, putting into it some energy. This energy can be pumped in using some light, flashlight, for example. This system is also in which this ruby is kept, or the material is kept, is called the laser cavity. This is same like microwave cavity resonators, where we keep the distance between the two walls as n lambda by 2. So now, as we said, there are three types of lasers. I mean, the material used in the laser can be three types, both all three types, like solid, liquid, and gas. Generally, solid lasers uses crystals like ruby, neodymium, glass, etc. Liquid lasers uses dyes, and gas lasers. One of the famous gas lasers is the helium neon laser. There are other carbon dioxide laser, and so on. The advantages, there are advantages and disadvantages of each of these systems. Now, first we see the basic diagram of a ruby laser, where you have a flash tube, circling the ruby rod. You can see on the screen. And one side of the ruby rod, on the left, it is mirror polished, whereas on the right side, it has semi-polished mirror. So between these two, this forms the cavity between these two mirrors. The ruby is enclosed in a electronic flash tube. The flash tube is nothing but a gas tube which contains some gas, and a fluorescent material around the glass is put up, so that when a discharge takes place inside the flash tube, the emission from this fluorescent material takes place. For a very short time, there will be a high intense light emitted by this tube. These were usually used in the olden days for taking photographs. Now this we use this flash tube, which requires a large amount of energy. This energy is obtained by charging a capacitor. We cannot instantaneously charge the capacitor, for you require a very high current source. So to charge the capacitor, we use a series resistor and a power supply, DC power supply. So due to this resistor will limit the current flowing into the capacitor. The energy stored in the capacitor is calculated as half CV square, where C is the capacitance and V is the voltage across the terminals of the capacitor. So this entire amount of capacity energy in joules, half CV square, if you express in if C is in farads, V is in volts, then the energy stored will be in joules. So when you strike this switch, this entire energy will be dissipated in a very short time by this flash lamp. Within a very short time, it will generate a high intense pulse of light, and that light pumps the electrons to the metastable state. And from the metastable states, when they come down, they emit laser beam. After a certain amount of reflections, they get strengthened and they come out as laser beam. Similarly, this also is very similar, where we have a dye laser, except that the pumping is pump is there, which pumps the liquid dye into this tube. And again, here we have a mirror here, and we have a half mirror on the right. And this blister window is nothing but a filter which determines which wavelength it needs to use as a laser beam. So by adjusting this one, you can actually change the wavelength for which this radiation will take place. So that is why these liquid lasers have advantages. They can radiate in certain frequencies, which UV laser can radiate only in one single frequency. Similarly, we have gas lasers. Its principle is same. It works with a gas inside a tube, and here you have two reflectors. And here, instead of a flashlight, we are using a DC power supply to energize the electrons, to energize the atoms, electron states. So a high voltage DC power supply is used as pumping source. Now, there are certain applications of laser. The most common application is there on your desk of the presenter. There itself you can see that is the laser pointer used for seminar presentation. And we have several. These pointers are not to be taken in a very lighter manner, because they are available very cheap, and so, but they are very powerful. And once we have seen that when we point, you can a close by aeroplane can receive these signals. If you just try to signal them, I don't suggest anybody to do that, but they can see that. So they travel a large distance. So they are not very simple devices. Then in optical drives, we use nowadays. These optical drives are very rarely used, but once upon a time, the CD, DVD, Blu-ray discs were very much used by people. Then we have laser machine cutting tools, military defense applications, and laser imaging and holography, medical applications, and radio telescope pointing. So this is the PPT slide laser. Everybody can. Okay. On the CD, you can see there are spiral tracks on the tracks. A laser beam, while the CD rotates, a laser is pointed on the tracks. This laser is so powerful that when it is made on, it can create a trench on the CD. So this is for writing. So there are two type of marks that the laser can make on that. One is called pit, another is called land. On the screen, you can see this is the pit, the small one, and this is the land. So when once you write the data for reading, you point. Okay, when you transit from a land to a point, or from a point to a land, it is taken as binary 1. And on the when there is no change, it is taken as 0. So while writing, you do this the speeds and lengths you create on the disk depending on the data what you get. While reading, you use a low power laser which cannot make any change on the disk, but they can bounce the light beam from this surface and detects the peaks and the lands, and thereby recovering the data. Now you have seen CNC machines. One of the best example of CNC machine is the XY plotter. XY plotter in the laboratories and all, where you instantly can draw something on the computer and take a diagram of it using this XY plotter. This CNC cutting sheet metal machine consists of a XY plotter and a laser. Instead of a pen, it has a laser. So the point where you want to move the laser is generated by giving the XY coordinates. So the pen will go there, the laser pen will go there, and there is another control which operates that laser on off. So this is done at very high speed. So first, when you want to make you make the drawing what you want to cut out on a sheet metal, and then feed it to the computer. The computer will move the laser according to the drawing, and it will remove the surfaces. So when the laser ray is put on, it actually melts the surface of the metal and thereby making a hole on it. And if you move it on, it will cut out holes of your required shapes. Then in defense applications, we use high power laser. One is, some people must have heard of Kali, kilo ampere linear integrator, but that is not a laser. It is an electronic pulse generator. This has been developed by DRDO, and there are a lot of stories how they created an avalanche in Pakistan. So there are a lot of stories about that. And this is what I am showing here is not Kali, but this is Durga. Durga stands for Directionally Unrestricted Ray Gun Array. So on the screen you can see that there is a light source here. This light source is a laser source, and it is created by several lasers together. They have been formed in such a way that a high intense laser beam is produced. In 2018, DRDO conducted a successful test of a truck-mounted laser system. The laser beam hit a target located 250 meters away, and it took 36 seconds for it to make a hole in a metal sheet. So this is the status of this Durga 2 in 2018. Today, it has more improved, but we really do not know the status of that. In holography, people have been using laser from long time, and the person who actually invented this was awarded a Nobel Prize for this. So holography uses interference as the tool for generating a 3D pattern. So interference can be generated not from multi-wavelength light, but it has to be generated from a single wavelength light. Then only you can create interference. So on the screen you can see that there are two lights that is created by splitting a source of light, that is a laser light, A and B. Some of it is reflected by this mirror M and put on the photographic plate, whereas the other portion of the light, that is B, it goes and strikes the object. The reflected light from the object comes on the screen of the photographic plate, and where it interferes with the A beam. So interference fringe pattern is produced, which is recorded on the photographic plate. Now for observing this 3D image, one requires the same wavelength light, that is from the same type of laser, put on the photo film called Gieber's plate, named after the inventor of that. So when it falls on it, this interference fringe pattern will be visible, and it will be visible at a distance on the right side, and there will be maxima and minima that you can observe by moving your right up and down or rotating it on the right side. So at some place you will get a good image where you can see some of these portions. Another, as you move down, you will see some other portion of it, and you will get really a three-dimensional image. Laser is also used in eye surgery. So you know that people are at the age of 40s or after that, they generally get this. They cannot read things because it appears to them blurred. That is because the lens of the eye gets deformed, and also the distance from the lens of the eye to the screen inside the eye, that gets reduced. So the solution for this is that you change the power of the of your eye lens. So this eye lens means I am talking about the cornea that is inside the eye. So for that you have to reshape the cornea, and for that laser is used. So on the screen you can see this. First on the eye, a anesthesia is applied so that the fine membrane protecting this your eye lens is cut out, so that your cornea is visible. Now this flap is removed, and then laser is applied to reshape your this lens cornea. Then this is the reshaped cornea, and then you put the flap back into the position, and the vision gets corrected. So it looks very simple, and it also takes very short time, but it is risky. It is highly risky. Still, we see that the adaptants, people are adapting this, and it's very useful. Now, finally, there are many other applications, many applications of laser. But I will come to one last application of this. This is on radio telescope pointing. At many places, we use a laser beam, especially for single dish large telescopes. This is in West Virginia. I had the opportunity to go there in 2000. And I climbed this dish. This is 100 meters in diameter. It's a heavy dish. It's a super heavy structure. You can't imagine. If you can see the people standing below, and maybe you will get more details of this if you give a Google search, GBT, Green Bank telescope. So this is a offset feed dish. That is the parabola. The feed is not at the center of the parabola, but it is at the side of the parabola. And this surface of the dish is made up of small iron plates, small plates like honeycomb, and each plate can be adjusted up and down. They can be moved so as to collimate the raise the radio astronomy signals that's falling on it to the feed at this point. I will show you the next diagram. So here you can see this. You see these blue lines. These are the incoming signals from the sky, and they are to be focused at the collector here. Here you have a antenna feed here which collects, and there is a sub-reflector here. So it gets reflected and then gets collimated here. So the distance from for this ray, the distance from this point to this point should be plus from this point to this point. If you add these two distances, that should be same as the distance from this point to this point. The same it should be for from adding from this point to this point. So you get a same wavefront. So for this, what you do is you align the plates that is fitted over here. All of these plates has to be aligned. So there is a laser beam that is focused from this plate, from this point, and on the plate, and gets a reflection and gets the distance. The distance is measured. So this way, when there is a computer which actually does this thing, it actually aligns this reflector in such a way that becomes focused at the point. Now you can ask that why you require focusing. You can make it once. So as I said, that this is a very huge structure. So due to the gravity, the structure will take a different shape at different angles. So that is corrected by this laser. So the laser ray is used for a perfect alignment of the dish surface made on the small metallic plates for a coherent focusing of radio signals on the antenna feed. Thank you very much. Hello.
Thank you, sir. Now we will quickly move on to the question session. Anyone in the crowd want to ask sir any question?
Sir, I have a question.
Yes.
In the geometry arrays, can we use laser as a communicating medium?
Where do you want to use the laser?
Laser.
Well, geometry array is a passive system. It is not a communication system. It actually collects the signals that is coming from the radio stars. There it is not used. It is not used there. It is only used where you have this problem of structural deformation. So in the last slide, what I showed is the structural deformation due to gravity that may defocus the dish. So it is for local adjustment of the dish. But in geometry, antennas are not that heavy as that of the GBT, where we use these lasers. Did I answer the question properly?
Yes, sir.
Thank you, sir. Now I'd like to call Professor Pranavee Maji on stage to give the certificate of appreciation to Professor. Sir, please.
Thank you very much, madam. Thank you.
Thank you, sir. Thank you, sir.
Thank you very much. Have a nice day.
Now, I think is the time most of you all have been waiting for. It is the time for us to announce the winners of the poster competition. To announce the winners, I would like to call Professor Sinha Mahapatra to come and announce them, and Professor H.S. Maji to give away the prizes. Madam Reena Bhattacharya, you come.
Okay, the third prize goes to Nivi Ghosh.
First prize jointly shared by Somadeep Roy and Rifat Pranab.
First page is. They are presenting one question. Congratulations. So, separate memento will be prepared for the other one. And we will
Now, before we proceed, I'd like to remind you all that our students have set up demonstrations for light-related experiments. We request all your presence. I'd like to call on stage now Professor Abhiksina Mahapatra to give his vote of thanks. Sir. Madam Pranavi Maji. Good afternoon to all. It's my pleasure to deliver the vote of thanks for this event to all dignitaries assembled here. On behalf of organizing committee, I would like to thank our guest speaker, Professor Shoramsu Mukhopadhyay sir and Dr. Shubhendu Juwarkar sir, not only for sparing their invaluable time for us to grace this occasion, but also for enlightening us with their commendable talks on this subject. I would like to thank our Honorable Vice Chancellor Sir, Professor Inversion sir. My special thanks to Dr. Manpreet Singh Manna sir, National Coordinator of Prakash Party, for his guidance in this respect. I express my heartfelt thanks to the Director of IQAC cell, Professor Himanshu Mali sir, for his constant support. I am running short of words to express my humble thanks to our Dean sir for doing poster evaluation. I would like to thank all HODs of all departments in our university, all faculty members, staff members, participants, and last but not least, our beloved students for making this concert. I thank one and all present here. Thank you all. The practical demonstrations done by our students